Chapter 13, Set C. A deck is shuffled and 2 cards are dealt. Find the chance that the second card is a heart, given the first card is a heart. 12 out of 51. There are 13 hearts and there are 52 cards. So the first card is a heart, which means there are 12 hearts left and 51 cards left. So it would be 12 out of 51. Find the chance that the first card is a heart and the second card is a heart. So the first one, there are 13 hearts and 52 cards. We're going to multiply that by 12 out of 51. So 13 times, I'll get it right, 13 times 12 divided by 52 times 51 is, oh, that's going to simplify. So 156 divided by 2652. One out of 17. Okay. Number 2, a die is rolled 3 times. Find the chance that the first roll is an ace. 1 out of 6, as long as it's a fair dice. Find the chance that the first roll is an ace, and the second roll is a deuce, and the third roll is a tray. What's the probability that the first roll is a 1? 1 out of 6. Now, is the second roll dependent or independent of the first? Totally independent. So getting a 2 has a chance of 1 out of 6, and getting a 3 has a chance of 1 out of 6. So it's 1 out of 6 to the third, which is 1 out of 216, I believe. 1 out of 6 to the third would be 1 out of 216, which is about 0.5%. Okay, a deck is shuffled and 3 cards are dealt. Find the chance that the first card is a king. It'd be 4 out of 52, which is 1 out of 13, which makes sense because there are 13 different numbers, so 1 out of 13 of them will be a king. Find the chance that the first card is a king, the second card is a queen, and the third is a jack. Are these dependent or independent? Dependent. So we're dealing 3 different cards, and we want king, queen, and jack. What's the chance that the first one is a king? 4 out of 52. What's the chance that the second is a queen? 4 out of 51. How many cards have been dealt? Only 1. 51, and then 4 out of 50. Now wait a minute, what if the first one is a queen? Then you lose and you're out. So we don't need to count, right? We're only counting the chances that we actually win. So if the first one is a queen or a jack, we lose. So we have a 4 out of 52 chance of winning the first card. If we win the first card, then we have a 4 out of 51 chance of winning the second card. And yeah, this isn't going to be very good. So 64 divided by 52 times 51 times 50. Yeah, that's... So, is that what you got? 64 over... Yeah, it's 0.00048. It won't even turn it into a fraction because the bottom is so big. All right. A die will be rolled 6 times. You have a choice. To win $1 if at least one ace shows. To win $1 if an ace shows on all rolls. Which game do you want to play? The first one. Yep. Okay, number 5. Someone works example 2A in this way. For me to win, The queen can't be the first card dealt. So 51 chances in 52. And she must be the second card, 1 out of 51. So the answer is 1 out of 52. What's wrong with that? So, so is 51 out of 52 correct? No, because there are 4 queens. Oh. Oh, I see. Oh, so the the computation is correct, but the the problem was interpreted incorrectly. All right. Okay, number 6 was confusing, but you have to put heads and tails in there. So a cat O9 tails can be used to punish heads of state. But this is seldom done. A coin is tossed twice to fill in the blank. What is the chance of the coin getting it right? 1 out of 4. So we could have HH, TT, HT, or TH, and only TH is correct. So 1 out of 4. A coin is tossed 3 times. What is the chance of getting 3 heads? 1/2 times 1/2 times 1/2. Because those are independent. Okay, if they were dependent, it doesn't work. You can't toss 3 coins if, right? You couldn't toss a coin 3 times if they were dependent. You'd run out of options.